Okay, so this next part, same idea. I just want to be careful with parentheses sometimes because they sometimes throw us off. So on this first one, we've got 5 over 2x to the third, no parentheses involved. So to rewrite it, I'd put the 5 halves as my coefficient, x to the negative 3, and then I do, I swing, multiply. So I get negative 15 halves, subtract 1, and then bring it to the bottom, right? So just kind of reviewing and practicing here with fractions and multiplying and subtracting and moving your exponents, exponent rules. Okay, so really be careful with stuff because it does get a little complicated in there, but you guys know the rules, so just apply them. All right, so this next one, the denominator has that quantity 2x to the third. So what I would do there is I would first distribute that exponent. So it's really 2 to the third, x to the third. Well, 2 to the third we know is 8, x to the third. And then I can really separate out the coefficient from that variable. So I'll have 5/8 x to the negative 3. And then I can differentiate. So I'd get what? Negative 15 over 8. This would be negative 4, so x to the 4th on the bottom. Kind of skipped a step in there. Are you guys okay with that? They're kind of fun, right? Who said calculus was hard?
Everyone.
So 7 over 3 x to the negative 2. You guys got this? Move that up first, so you'd have 7/3 x squared. Differentiate. That's it, right? Now with this one, that negative 2, okay, so be careful. You can, again, distribute it to both if you want, right? Or however you want to do this, right? You can either distribute first or move it first. I'm kind of a fan of moving this whole thing up first. Move that whole 3x to the negative 2, move it all up to the top. So now it's 3x to the positive 2 on the top. That's going to be a little quicker. Then I can distribute. So now I have 7 times 3 squared x, which is just 63. Thank you. I had a moment. Oh, x squared. Sorry, that's what I was missing. Right? Because 9 times 7 is 63. And now differentiate. So what is that? 126 x to the first. Kind of simplified pretty nicely. Okay. It would still work. So let's see. If I leave it here and distribute, so I would have 7 over 3 to the negative 2 x to the negative 2. So you can, 3 to the negative 2, you're going to get this complex fraction, is 1/9, right? And then x to the negative 2 is just, if I can move it up to the top, it'd be x squared up here. You get the same thing. So 7 divided by 1/9 is really like 7 times 9 over 1. So I'm still going to get that 63x squared there. So either way, you should get the same answer. I think it's just a little trickier because you have the 1/9 in the denominator. Okay. Exponent rules, exponent rules, exponent rules. I'm doing well, I'm doing well. All right, so now what about a longer polynomial? All the ones we've done so far just had one term. What about like a trinomial or like a 4 terms or 5 terms? What do? You just do each term at a time, okay? So look at this first one. I've got x cubed minus 4x plus 5. You just take it one term at a time and differentiate each one. So what's the derivative of x cubed? 3x squared. And then what's the derivative of negative 4x? Negative 4. And what's the derivative of 5? 0. That's the constant, right? So anytime it's a constant, you can really just drop it off, right? Because it's just going to be 0. So those constants I don't really care about. And my answer is just 3x squared minus 4. Okay, try letter B. each one separately. And then check your answers. I got negative 2x cubed plus 9x squared minus 2. Good? Right? So that's all you gotta do for nice long polynomials, okay? So just go through and do each one at a time. That's it, you guys. That's power rule. Okay, so now you have learned this nice shortcut. It's gonna work for any of these types of polynomial functions, anything with an exponent, anything with a power. Okay, and later on you're gonna like take this same rule and you're gonna apply it to other things. Okay, so it really is gonna keep coming throughout the whole year. Okay, or throughout all of calculus, it keeps coming. What about sine and cosine? I'm just going to do a quick little thing here with some trig functions. What's their derivative? Well, they're not obviously a polynomial, right? They're not in a power, like, exponent thing. So they just have a rule that you just need to memorize, okay? So it's very simple. The derivative, that's what this notation means, right? Derivative of sine with respect to x is cosine. So the derivative of sine is cosine. Simple enough. And so therefore, the derivative of cosine is, oh, whoops. There's a negative here, okay? So it's not that easy. Just remember that one does get a negative. The derivative of cosine is negative sine, okay? That's it. Memorize. Say it again, hon? Yeah, so with coefficients, let's look at the example here because it'll show you what to do with coefficients and things. All right, so write yourself a little note. Memorize it. Pretty simple, easy. Don't forget about the negative on the second one. So, for example, y equals 2 sine of x. With a coefficient in front of it, you're just going to keep the coefficient in front, and then you're going to take the derivative. The derivative of sine is cosine, and you're done. That's all you got to do. Later on, you guys are going to learn a thing called the chain rule, which would be in case, like, instead of just an x here, what if it said, like, the sine of 2x or the sine of 5x or something else in here? Then you would use the chain rule for that. So we're not there yet. So we're just dealing with coefficients in front. So if you have a coefficient, the coefficient stays there. So like for this next one, this would be like a coefficient of 1/2. So it would just stay there, and I would derive. So it would just be cosine of x over 2. For this next one, we've got x plus cosine of x. So a linear plus a cosine. Again, just do each one separately. So what's the derivative of x? 1. And what's the derivative of cosine? Negative sine. And you're done. That's it. Okay? So again, this part should be pretty simple and pretty easy to be able to just work through. It gets tricky with the exponents, but work slowly. You guys will be fine. All right, I know it's a lot. This is the last part. And it's your favorite. I saved the best for last. We're going to talk about physics, you guys.
Oh, great.
I know. You love it.
I just did Amy's test.
I don't want to do any more physics forever, the rest of my life. It's very easy. It's mathy physics, so it's not hard. So we're talking about the connection, and a lot of people say, well, great, all this derivative stuff, it's slope, it's power rule, but how does it connect to the real world, right? So here are some applications. We know slope really is another way of just talking about a rate of change. So really a lot next year you're going to hear in calculus using that phrase, rate of change, instead of saying slope as much, okay? The derivative is the rate of change with one variable with respect to another. Some applications: population growth, production rates, water flow rates. That's a big one. Next year you're going to do all these problems with, like, there's a pipe and there's water flowing out it at a certain rate, and you have to figure out all this stuff about the water flowing out of a pipe for whatever reason. And then the big ones, which we'll talk about today, are velocity and acceleration. We won't get to today, but we'll talk about that later. So rate of change, for the main part, we're going to talk about a position function, right? So you've got a position function. All my juniors know this. We use S to represent our position function. Yes. No, I don't know these people. These are not my room. No, wrong room. These ones. This is my only one. Melanie, you have mail. All right. So average velocity, and that's what we want to talk about today. Average velocity is just change in distance over change in time. Another way I'm going to say this is this would be like S of T2 minus S of T1 over T2 minus T1, right? It's your y2 minus y1 over x2 minus x1. It's just slope, right? That's what average velocity is. So let's look at this example, and I'm not even going to work through the whole thing, but I'll just set it up for you. They give us the position function. This is my s of t function. And I want to know the average velocity over each of these intervals. So I want to do s of 2 minus s of 1 over 2 minus 1. So I would just plug in a 2 here to get s of 2, right? I'd just plug it in, and then I'd plug in a 1, and then I'd type this on my calculator, and I'd get some answer, and it would be feet per second because it's average velocity. It is pretty simple. Okay, so you're just practicing when it says average velocity, you would just do s of the second one, whatever your s function is, and again, you type it all in your calculator, and you get your answer. I just don't want to go through and do all that right now because I think you guys get the idea. Okay. Again, whatever your function is, type it in, plug it in. Same idea with this one. S of 1.1 minus S of 1 over 1.1 minus 1. Get your answer, and you're good. Okay. That's average velocity, right? So like average velocity is over a period of time, right? I drove from here to, Nebraska, right, whatever. And it took me however many hours. What was my average velocity, my average speed the whole time I took the trip? Okay, that's average velocity. What about if I just want the velocity at one certain exact moment? I want to know what was that instantaneous velocity. It's not 0. Acceleration is 0. There is. And guess what? It's a limit. It's the limit as your time is going to 0. I don't know why it was weird the way it typed out. So here it is, right? This is what an instantaneous velocity. You're right? At that exact instant, there's no change in time because the change in time is going towards 0. So you're taking the limit as delta x is going towards 0. Oh, this looks familiar. Guess what it is? It's the derivative. It's just the derivative. And you don't have to do the long way. You can now use power rule, right? So if I want to find instantaneous velocity, it's just the derivative. It's the derivative of your position function. And then guess what acceleration is going to be? The derivative of velocity. Or the second derivative of position. So you'll get there later. But for now, we're just going with, from position, the derivative of position function is instantaneous velocity. If it doesn't say average, assume instantaneous, which just means derivative. Okay? So we've got a diver. Time equals 0. They jump from the platform, 32 feet above water. There's your function. When does the diver hit the water? We got to figure out what the time is when he hits the water. So how am I going to do that? Well, I go with 0 because it's 32 feet above water. So 0 is going to be at the water. So let's go 0. Yeah. So 0 would be negative 16t squared plus 16t plus 32. Let's solve for t. So we can get rid of those numbers. Let's divide everything by negative 16. That should factor pretty nicely. What do you guys get for t? So t would be positive 2 and t would be negative 1. We can't have a negative time, right? So after 2 seconds, it's a long time in the air, isn't it? I guess that's normal. 32 feet, is that long? I don't dive. 2 seconds, so is that fast? Okay. This is a very fast diver. I don't know anything about diving. It seems slow to me. 1. I don't know. Maybe it's not. How high is 32 feet? How high are we right now?
10 yards.
10 yards is 32 feet? It doesn't help me. What is 10 yards? How tall is this? Like 12 feet?
Yeah, probably this building is probably 32 feet.
So that'd be a big jump. Okay. Anyways, it's not slow. So it's fast? Oh, I'd say slow to me. What is the diver's velocity? Could you do some flips in 2 seconds? Yeah? Sure, just thinking. Okay.
You just flips 1 second.
So velocity at impact is instantaneous velocity, right? We're looking at instantaneous velocity, which means derivative, which means I need to find s prime of t. That's going to give me my velocity. So I do s prime, which means I got to do power rule for this guy. So go ahead and do your power rule here. What will we get? What's happening? Negative 32t plus 16. That's it, right? It'll be 16t to the 0. Okay. That's my function, but I want it at time equals 2 seconds. So I got to plug in a 2 here. So my velocity at 2 would just be negative 32 times 2 plus 16, negative 64 plus 16. Is that right? Feet per second. That's pretty fast. He's going negative 48 feet per second. Why negative?
He's going upwards.
He's going which way?
Upwards.
No, he's not. He's going down. He's going down into the water. That's the negative. I am so good.
He's hovering.
I just gotta say.
Did you finish all of them?